Hello, geometry scholars. We are up to 7.3, and this is another chunky subject. We have another 4 theorems, plus this concept summary that I'm going to start with right here, just right at the beginning of the section. Just you could pause it. What this section has to do with is identifying and verifying parallelograms. So if you need to know how to identify and verify a parallelogram, then we're going to talk about all the different ways you can prove that a quadrilateral is a parallelogram. Necessarily, this will involve proofs if we're going to prove. So here are the 5 different ways you will learn in this section. So it's a long section, okay, with a lot of information. But we'll go through each section step by step, and then we will do some examples also under the camera. So the first thing you're going to do is show that both pairs of opposite sides are parallel. That was the definition we went over in section 2. Another way you can show that both pairs of opposite sides are congruent, which is the converse of the definition. You could show that both pairs of opposite angles are congruent, which is the parallelogram opposite angles converse. You could show that one pair of opposite sides are congruent and parallel, which is both of them combined, opposite sides parallel and congruent theorem. And also you can show that the diagonals bisect each other, which is the parallelogram diagonals converse, because all of those we had in section 2. Now we're going to use that information to prove that a quadrilateral is a parallelogram. So let's start with the objectives and vocabulary. Previously, we talked about diagonal and parallelogram. In this section, we will identify and verify parallelograms, as well as show that a quadrilateral is a parallelogram in the coordinate plane. Again, I'm not sure if we're going to do the coordinate plane problems, but for sure we're going to put them in here because more information is better. Here we go. So, given a parallelogram, you can use the parallelogram opposite sides theorem, which is 7.3, and the parallelogram opposite angles theorem, which is 7.4, to prove statements about the sides and angles of the parallelogram. The converses, which was 5 and 6, were different theorems, so now we're going to talk about the converses of all 4 of those. You can use these and other theorems in this lesson to prove that a quadrilateral with certain properties is a parallelogram. So here is 7.7. Parallelogram opposite sides. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if AB is congruent to CD and BC is congruent to DA, then you know that ABCD is a parallelogram. Also, the angles converse says, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you know that A is congruent to C and B is congruent to D, remember opposite sides, then ABCD is a parallelogram. There is a proof. It's on page 39. It's example 39 in your book in this section if you want to find it. Here's another proof of the converse. Okay, so the plan for this, if you know that you have AB congruent to CD and BC congruent to DA, then what you would do to prove it is you would talk about the diagonal AC. Then you would use the side-side-side congruence theorem to show that the 2 triangles are the same. And finally, you can show with the alternate interior angles converse theorem that the opposite sides are parallel. So it's a pretty simple plan. Here's how you do it exactly. If you'd like to study it more, pause the video and go on. Go on when you're ready. Here's some examples on how to identify a parallelogram.
An amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth, higher and higher, until it goes over the top and around in a circular motion. In the diagram below, segment AD and segment BC represent 2 of the swinging arms, and segment DC is parallel to the ground, line L. Explain why the moving platform, segment AB, is always parallel to the ground. Solution. The shape of quadrilateral ABCD changes as the moving platform swings around, but its side lengths do not change. From the diagram, both pairs of opposite sides are congruent, so ABCD is a parallelogram by the parallelogram opposite sides converse. By the definition of a parallelogram, segment AB is parallel to segment DC. Because segment DC is parallel to line L, segment AB is also parallel to line L by the transitive property of parallel lines. So, the moving platform is parallel to the ground.
And that's it. So, here's a second example where we're finding the side lengths.
For what values of x and y is quadrilateral PQRS a parallelogram? Solution. By the parallelogram opposite sides converse, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Find x so that segment PQ is congruent to segment SR. Set the segment lengths equal. So, PQ equals SR. Then substitute x plus 9 for PQ and 2x minus 1 for SR. Now solve for x. First, subtract x from each side of the equation to get the equation 9 equals x minus 1. Then add 1 to each side of the equation. This gives you 10 equals x. When x equals 10, PQ equals 10 plus 9, which equals 19, and SR equals 2 times 10 minus 1, which equals 19. Now find y so that segment PS is congruent to segment QR. Set the segment lengths equal. So, PS equals QR. Then substitute y for PS and x plus 7 for QR. Next, because x equals 10, substitute 10 for x. Now add. 10 plus 7 is 17, so y equals 17. When x equals 10 and y equals 17, PS equals 17, and QR equals 10 plus 7, which equals 17. So, quadrilateral PQRS is a parallelogram when x equals 10 and y equals 17.
Some algebra for you. So now we're going to go through a couple of more theorems. Hopefully you'll see how those are used, and we'll practice that in the assignment. Theorem 7.9 says, opposite sides parallel and congruent theorem. If one pair of opposite sides of a quadrilateral are congruent, and they're also parallel, so if you have both of those conditions, then the quadrilateral is a parallelogram. And so you can prove that in other ways. There is an example, 40, that proves it in the book. Also, the parallelogram diagonals converse. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So this is in section 7.2, where we learned that diagonals of a parallelogram bisect each other. So this is the opposite. If you get that you have two diagonals bisecting each other, then it's a parallelogram. So we're going to go ahead and do some examples where you see how that is in use.
The doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV equals TU. Solution. In the photograph, segment ST is parallel to segment UV, and segment ST is congruent to segment UV. So, one pair of opposite sides of quadrilateral STUV are parallel and congruent. By the opposite sides parallel and congruent theorem, quadrilateral STUV is a parallelogram. Then, by the parallelogram opposite sides theorem, you know that opposite sides of a parallelogram are congruent. So SV equals TU.
That's it. Okay, we're going to do another example, finding diagonal lengths of a parallelogram, so we can look at the converse.
For what value of x is quadrilateral CDEF a parallelogram? Solution. By the parallelogram diagonals converse, if the diagonals of CDEF bisect each other, then it is a parallelogram. You are given that segment CN is congruent to segment EN. Find x so that segment FN is congruent to segment DN. Set the segment lengths equal. So, FN equals DN. Then substitute 5x minus 8 for FN and 3x for DN. Now solve for x. First, subtract 3x from each side of the equation. This gives you 2x minus 8 equals 0. Next, add 8 to each side of the equation. This gives you 2x equals 8. Finally, divide each side of the equation by 2. This gives you x equals 4. When x equals 4, Fn equals 5 times 4 minus 8, which equals 12, and Dn equals 3 times 4, which equals 12. So, quadrilateral CDEF is a parallelogram when x equals 4.
I'm hoping that you can not only see how this works, but also just figure out whatever it is that the theorem needs, figure it out that way, and then solve the problem. Okay, so we're going to go on to the coordinate proof part, and here's where we started again, the concept summary. So if I ask you to prove that a quadrilateral is a parallelogram, these are all the different ways you can do it. You've got 5 different ways now. Okay, the definition, and then those 4 theorems. So we will be doing more proofs. I know you're excited about that. Now let's do a little coordinate geometry. Again, I may or may not assign these from the book, but it is an example that you should be able to follow through.
Show that quadrilateral ABCD is a parallelogram. Solution. Method 1. Show that a pair of sides are congruent and parallel. Then apply the opposite sides parallel and congruent theorem. First, use the distance formula to show that segment AB and segment CD are congruent. AB is equal to the square root of the quantity 2 minus negative 3 squared plus the quantity 5 minus 3 squared, which equals the square root of 29. CD is equal to the square root of the quantity 5 minus 0 squared plus the quantity 2 minus 0 squared, which equals the square root of 29. Because AB equals CD, which equals the square root of 29, segment AB is congruent to segment CD. Then use the slope formula to show that segment AB is parallel to segment CD. The slope of segment AB is equal to the quantity 5 minus 3 divided by the quantity 2 minus negative 3, which equals 2/5. The slope of segment CD is equal to the quantity 2 minus 0 divided by the quantity 5 minus 0, which equals 2/5. Because segment AB and segment CD have the same slope, they are parallel. Segment AB and segment CD are congruent and parallel. So, ABCD is a parallelogram by the opposite sides parallel and congruent theorem. Method 2. Show that opposite sides are congruent. Then apply the parallelogram opposite sides converse. In method 1, you already have shown that because AB equals CD, which equals the square root of 29, segment AB is congruent to segment CD. Now find AD and BC. AD is equal to the square root of the quantity negative 3 minus 0 squared plus the quantity 3 minus 0 squared, which equals 3 times the square root of 2. BC is equal to the square root of the quantity 2 minus 5 squared plus the quantity 5 minus 2 squared, which equals 3 times the square root of 2. Because AD equals BC, which equals 3 times the square root of 2, segment AD is congruent to segment BC. Segment AB is congruent to segment CD, and segment AD is congruent to segment BC. So, ABCD is a parallelogram by the parallelogram opposite sides converse.
So hopefully you followed. There's 2 different ways to do it, and with 5 different ways to prove that it's a parallelogram, you might do it differently than I might do it. It's just one way to do it with coordinate geometry. This is just some practice problems, and here we go. You should be able to go straight on over to Big Ideas Math, and C7L3 or Practice 7.3 will be in that dashboard for you, ready to go. You have a few days to get that done, and definitely rewatch the video if you need extra help and or ask for help in class.